Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and WhiteSource. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting presentation ahead, but first I have just a couple of housekeeping notes to cover. First, today's session is being recorded, so if you missed any of our discussion or you'd like to share with a friend, the on-demand recording will be made available shortly after we conclude our live webinar today. If you have any questions for our speakers, we want you to direct those to the Q&A tab on the right side of the screen. And that's also where you'll find the chat box. We want you to use that chat box to engage with your fellow audience members, tell us where you're from, give us any kind of information you know or want to contribute to today's webinar. And finally, at the conclusion of today's session, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic for today's webinar is Mitigate Risks in Code, Protect Your Software-Based Supply Chain. And I'm joined today by Mo Curiel, Director of Product and Cloud Native Solutions at WhiteSource, and Guy Barr-Gill, Head of Product-Led Growth at WhiteSource. So to the both of you, Mo and Guy, thank you both so much for being here with me. I'm going to let you take it away from here.
Thank you very much, Cody. Thank you everyone for joining us today. Before we are jumping into the actual agenda and the content, I want to do a short introduction about what is WhiteSource to the people who in the audience who are not aware of the company or not sure what we're doing. WhiteSource is building an AppSec platform which is built for agility, which means we are helping you guys secure your application and go beyond mere detection and prioritization, and giving you tools to remediate centric application security solutions. We know that with the entire digital transformation and the movement to the cloud, the focus and the pressure is being pushed and focused on your developers. So we are focusing also on developer integration to provide you with a secure SDLC with native integration and give you visibility and remediation right directly to the developer platform and to the developer environment. And we are doing it with our unique offering, our products. The first one is WhiteSource SAST, which helps you guys secure your code. The second one, Defend, which helps you to secure supply chain security. And the last is secured application, WhiteSource SCA, that gives you visibility into open source security vulnerabilities and containers or infrastructure as code issues. Now let's jump into the agenda. What we're going to cover today. Today we're going to focus on supply chain security and all the issues and the problems and how we are planning to solve them. And we're also going to present one of WhiteSource open source tool. Go and download it, by the way, at the end of the slide, or the end of the webinar. WhiteSource Renovate. Guy is going to cover that. We're going to address the challenges that we have with shifting to the cloud, and we're going to better understand why shifting left is a good start, but it's not enough. We're going to review the CNCF supply chain security best practices, and from there, we're going to move into the Secure Software Factory, an open source project that was created lately. And from there, Guy's going to take the lead and discuss the importance of up-to-date dependencies and how to introduce automation into your SDLC. Going to demo the WhiteSource Renovate, and then we're going to open it for questions. The purpose of technology is to solve problems for your business, not to become one. This is the line from the bottom of the slide. It's very important to understand this, because when we move to the cloud, we are introduced to the new methodology that which is called DevOps and Agile SDLC, and we are releasing our code much faster and more developer teams, and we're moving to a new way of work. But if we're looking at your software supply chain and all the issues and all the problems that rise up in the last coming years, we see that attackers are focusing their attention on your CI/CD pipeline. They are leveraging vulnerable packages, exploiting existing vulnerabilities, or planting their malicious code in popular open source packages or private packages. They are focusing their attention on your pipeline tools and taking advantage of privileged access, misconfiguration, vulnerabilities in your CI/CD pipeline in order to compromise your pipeline, expose your source code, and this gives you this gives the attacker the ability to change your code, inject his own malicious code, and tamper with the application, and from there he can do whatever he wants. But the main thing that we are seeing, and this is according to the European Union Agency for Cybersecurity, 66% of emerging supply chain attacks focusing on the software supplier code, on the code and artifact integrity of your application. This is the main risk area. And this is also something that Guy now will present how you can address, how you can resolve and fix this challenge. And today, how we are solving this today. So one of the ways that we are usually doing this is we're ignoring it. Maybe it will fix itself. Another way is use another framework, another compliance, another set of rules, guide the users. When it's not working, blame the users. When they are training again and again, and it's a vicious circle. And in the end, so in the last couple of years, we saw that the shift left security is also being introduced. And this is something that we are not completely happy with, because the boundary of security does not stops at the source code. It goes from the actual source code into the runtime environment. And when you are shifting your shift left security, you don't have process validation. You don't have confidence that the required security checks actually run on the step that you wanted them to run. You don't have the integrity checks that you can get in to be ensured that the actual CI products were not tampered with, the artifacts were not any malicious adversary change your code or change the actual the artifacts, and you're using something that you thought was safe, but actually it's a malicious component. In the same way that happened with the Solar Blast security breach. And then the last challenge is you don't have agent validation, which means that you can't fully understand, and you don't have the confirmation that the people that or the system that are running the CI steps have are authorized to do this, and they are the actual identities that they have. Now, CNCF tried to solve this by creating a software supply chain best practices white paper. It's a very good guide. It's a reference architect that is cloud-native focused, and it gives us, it goes over pretty much 4 main principles: how to implement defense in depth into your pipeline, sign-in and verification, artifact metadata analytics, and how to introduce automation. The problem with that is that people don't know how to build software that is the right way for them. They don't know exactly how to take all the stuff that they just read out there and implement them into their environment. They don't know which open source project, which tool they need to use. Do I want to use Sigstore or Tecton or Caverno or OPA? What is the right one for me? It's not so obvious, and that's a big challenge, and that's a pain. And when I read it, I was a bit confused, because what I really wanted was a simple demonstration and how I can take all these frameworks, all these tools, and implement them in a very simple way. Now, for that, I'm very happy to present you guys with the SSF. The Secure Software Factory. This is an open source project that Citi recently contributed to the OpenSSF. It was written by Michael Lieberman and Brad Beck. You have a link over here, and it's a very simple implementation of how to take all the different best practices, all the different tools, and implement them. and how organization can use this in order to create a baseline implementation of the best practices that we read on the white paper of CNCF, and we use them in other systems. Okay, so the SSF helps us to implement, to resolve all the challenges that we saw on the previous slide. The provenance verification gives you tools and visibility in order to gain assurance that the origin of the artifact that you are using is actually the one that is the right one, and no one has been tampered it in the build step or in the other on the other steps. Gives you the assurance that the given artifact, please go back, gives you the assurance to the given artifact and the content that is being of that artifact is the one that you thought it, you think that is, and it's there intent. That's why it's intended to be used, and it's constantly checking the artifact dependency tree for trustworthiness and provenance, and ensuring that the artifact that you're using is not being tampered or the code has not been changed. The three main areas that the software supply factory, secure software factory, sorry, is focusing on is on the pre-build, which is the part of the open source component, the artifacts, all the actual code that the developer is writing and building all the different dependencies. And from there, it's more focused on the repo, on the repo side. Then we're moving to the second phase, which is the actual build step. The build step is the CI/CD pipeline. It gives you the assurance and the visibility and create the process of building, testing, and packaging the artifacts according to the best practices of the secure software factory. And we also the project also focuses on the post-build, the delivery, the deployment step, concerned with all the storage of the artifacts and how you're going to verify that when you're deploying the actual application or the component is actual, nobody's being tampered, nobody's been man in the middle, and constantly verifying. Now, Guy, what is going to do is going to give you the tool in order to implement security on the pre-build, in order to give you assurance that the artifact that you're using is let's say, the most secure one that you can have. Guy, please take it.
Thank you, Mo. Good stuff. Hi, everyone. So I'll take you through an example of what you can do in the pre-build stage to secure your software supply chain. It's really pretty simple. You can just keep your software dependencies up to date, and with this, you can achieve pretty impressive results with very little effort in comparison. And it's so effective that, in fact, the latest research from WhiteSource shows that over 90% of vulnerabilities in NPM packages, this is what the study was about, they have fixes before the vulnerabilities are actually publicly disclosed. So the implication of that is that if you're always up to date with your dependencies, you're already avoiding about 90% of new vulnerabilities. You can see the exact results of the study here on the right. So the study was about NPM CVEs in 2021. You can see that 90.7% of them were fixed before the CVE was published, and only 9.3% were fixed after the CVE was published and made publicly known. And you may be asking yourself why this is the case, and it's because the security researchers and the open source project maintainers cooperate between them. So the security researcher will uncover a new vulnerability. They will notify the open source project maintainer about that vulnerability. And once the open source project maintainer confirms that the vulnerability exists and they issue a security patch for it, then they'll notify the NVD, which is the National Vulnerability Database, where people go to view publicly known vulnerabilities. So they'll both tell them to release the information about the new vulnerability only after a security patch has been issued. And this is important because a study from the Ponemon Institute shows that known vulnerabilities are exploited in about 60% of breaches, which is a huge number. And besides this vulnerability prevention, there are a few other benefits of consistently keeping your dependencies up to date. And that's that you have access to the latest features, the latest APIs. You have access to all the recent bug fixes, so you get less buggy and applications and with more features. And you get to avoid what's called zero-day fire drills. And if you're not familiar with what a zero-day fire drill is, I can take you through the scenario, paint a quick picture for you. Basically like this. So a new vulnerability was just discovered. Let's say log4j, Spring4Shell. It seems to be very, very important. There's a lot of noise around it. And your company's customers are pressuring your company for an immediate fix because this vulnerability is making the company's customers vulnerable as well. And your company turns to you to fix this vulnerability. And you come to fix the vulnerability. You come to update the component which is vulnerable to the latest non-vulnerable version. And you realize that you are 18 months and 10 releases out of date on this component. And now you have an ultimatum in front of you. You can either remain vulnerable, or you can upgrade 10 releases without testing and risk breaking something in production. And you probably look like this guy here in the picture on the bottom right. So the question is, what would you do in this scenario? I personally would vote to avoid the situation by keeping my dependencies consistently updated. And then when the security patch is released, I can just click and update immediately without really thinking about it because the risk is so small and I can avoid this whole scenario. But staying up to date all the time requires a lot of work. So what you would need to do is you would need to understand all the time what dependencies reside in your software project. So that can be, for example, open source packages, it can be Docker images, and it can be internal dependencies that are developed by other teams in your company. You'll need to check to see if an updated version of those dependencies exists. You'll need to check that the upgrade won't break your build, so you'll need to run your tests on each upgrade. You'll need to read the release notes and see if there's any major functionality that's being changed. And you'll have to open a pull request to update the dependency. And then you'll have to repeat steps 2 to 4 of the process for each of your dependencies. And this is a very time-consuming process. And a report from Stripe with the results shown here on the right shows that developers spend about a third of their time, or 13.5 hours per week, working on reducing technical debt, which is just an enormous amount of time. And of course, dependency upgrades is a part of that 13.5 hours. And what can you do about that? Well, basically, you can automate the process, and I'll discuss how you can automate it with an example using Renovate, which is an open source tool by WhiteSource. And the way that Renovate works is it pretty much goes over all the steps I just described, but automates them. So it'll scan your project and identify what dependencies you have. It'll automatically check for updated versions of those dependencies and automatically open pull requests to update them. And it embeds all the info you need to make your upgrade decision easy within the pull request. So it includes the release notes, it includes the commit history, it includes the status of your tests, and it includes what's called crowdsourced merge confidence data, which we can see 2 examples of here on the right. So in this top example, we can see the packages post CSS. There's an upgrade from version 8.1.4 to 8.1.5. We can see that it's passing 75% of people's tests. So 75% of people would have thought that this update looks good to merge. But we can see with the addition of the Renovate stats that the adoption is on 0%. So nobody is actually staying on this package version. And the confidence in the upgrade is low. So clearly there's a problem here. People are upgrading and then rolling back or not upgrading at all because they've heard it's problematic. And this is a bad update, right? You would need to look deeper into it if you have to do the update, or possibly just avoid it, as opposed to the update on the bottom, which is updating a Maven dependency flattened Maven plugin from 1.2.5 to 1.2.7. You can see it's passing everybody's tests. Adoption is very high, almost 50%. And the general confidence in the update is very high. This one you can upgrade without thinking twice about it. And Renovate can also group your updates for you. So for example, you can group all the updates that look like this high confidence one together and have them in just one pull request. You can group together all patches or all minor updates, and you can schedule the updates so it doesn't disturb you during your working hours. So you can configure Renovate to
only update pull requests on weekends or after 6 p.m. when the team isn't working, or really whenever you want. And the way it works is pretty much that whenever a maintainer publishes a new version to the package registry, then Renovate detects that new version was published, and it opens a pull request to the downstream repo, and it embeds inside that pull request the merge conference data, which is calculated from over 400,000 repositories that Renovate is currently installed on. And it's really quite that simple. It's not more complicated, and I can show you what it looks like with a quick demo. So hopefully you can see my GitHub screen now. And so let's say that you're a developer who's working on an app, and the SecOps team or someone else from the organization reaches out to you and asks you to improve your dependency health, which is how up-to-date your dependencies are. Or you just want to get it done because it's a best practice, but you don't really know how and where to start. So Renovate can help you out with that. And we'll use this repo with Renovate installed on it to demonstrate how that can be done. So this is WebGoat. It's a deliberately insecure app, and we'll use it to demonstrate how Renovate can improve your dependency health and overall dependency management. So in this repo, we have several types of dependencies. And most importantly for our needs, we have this Docker file here, pretty simple Docker file built off Node 12 Alpine. We have this Kubernetes manifest deploying Nginx. So it's based off Nginx version 1.14.2, which you can see here. And we have this POM XML with all the Maven dependencies in it. There are quite a few here, quite a lot of dependencies. And we have this Renovate JSON, which is how we know that Renovate is installed. It has the Renovate configuration inside, also rather simple. And we can see all the out-of-date dependencies in the repo in an issue that Renovate opens for us called the dependency dashboard. So here we see all of the out-of-date dependencies that don't have pull requests open for them yet for updates for various reasons. And we have here all the out-of-date dependencies that Renovate has already opened pull requests for. And we can quickly see what a pull request that Renovate is open looks like. So for example, we have the Nginx application from before. We can see that we were basing it off of 1.14.2 earlier. There's a new version, 1.21.6. We haven't put in any specific schedule for it. I've disabled auto merge by config. So we have to manually merge it. We can rebase it if we'd like, and we can simply ignore it, of course. And we can see here the tests that were run, all of them passed. We can simply merge it. Or if we want to take a look at one of the Maven dependencies, and we can look at, JSoup. And we can see that this one is also a high confidence update. So it's an old update. Many people are using it, passing many people's tests, and the confidence is high. We can merge this one as well. One final one, maybe, the Node.js app. So again, we can see that we were using Node 12 Alpine before. There's an upgrade to Node 18 Alpine. I'll show you the release notes on this one, so you can see the release notes for version 18, 17, 16, so forth, and all the rest. And yeah, I think we can open it up for questions. So I'll read the questions that I see coming in. Let's see. All right, first question I see. Does Renovate reinforce other best practices for managing dependencies? So by other, I assume you mean other than keeping them simply up to date. The answer is yeah, there are some other best practices that Renovate can enforce. It reinforces, for example, pinning your dependencies to specific versions. So you don't want to just have like ranges of dependencies declared in your files, because then your dependencies aren't deterministic. For example, you can build the application 1 minute and the latest version will be 1.14, and you can build the application 5 minutes later and 1.15 has come out in those 5 minutes, and all of a sudden your application production is using 1.15 and you don't even know about it. So Renovate can also create pull requests that reinforce pinning your dependencies. It'll do that for you. It does that with Docker images as well. It can pin to specific hashes and some other stuff as well in that sense. Another question, where can I get Renovate? So Renovate is available in a few different places. There's a GitHub app. I put the link in the chat. Actually, Cody helped me out with that. There's a link there for the GitHub app, but it can also be used in an open source version. So it's on Docker Hub. It's on NPM. You can visit the GitHub repo. Those are really the main places where Renovate can be found. If you're having any trouble, you can message me by email that was shown at the beginning or on LinkedIn. I will gladly help you out with that or any other questions you have. Those are all the questions I see. So if anybody has anything else, send it in the chat now. Otherwise, I think we're done for today.
I just want to add something that I don't know if at least some of the guys here from Europe, but if anyone on the webinar is gonna be next month on KubeCon Valencia, please come to our booth. Let's talk. We're happy to meet you guys.
Yep, definitely.
So while we give our audience just a few more seconds to send in any final questions, I'm going to go ahead and give away a couple of gift cards. Does that sound all right with you guys?
Sure.
Yeah.
Awesome. So these are for 4 $25 Amazon gift cards. Our first winner is Kevin L. Our second winner is Charlotte B. Our third winner is Karomo T. And our fourth and final winner is Rashana L. So to the 4 of you, congratulations. Keep an eye on your inbox to claim that gift card. And if you don't receive an email, just check your spam folder. And also take this opportunity to remind our audience that the session was recorded. So if you'd like to rewatch or share, you will receive an email with a link to access the recording on demand. And you can also find it on the DevOps website at devops.com/webinars. So I'm not seeing any more questions for you guys. So anything that you'd like to leave the audience with before we close out?
Just to come meet us at KubeCon.
Meet us at KubeCon. If you have any questions, please feel free to reach out to us. Email, LinkedIn. We're here for you guys. We would love to have an open discussion about these topics. I'm a cloud native fanatic guy, just fanatic, So we would love to have an open discussion.
Excellent. Well, Mo and Guy, thank you both so much for taking the time to join us today. I know a lot of work goes into these presentations, so I appreciate all the hard work and the expertise that you guys brought today. I would also like to thank WhiteSource for sponsoring today's webinar. We couldn't have done this webinar without WhiteSource. And my final thanks, as always, goes to you, our audience. We appreciate the time that you spend with us. We just ask for one extra moment of your time to fill out a quick post-webinar survey. But otherwise, we do hope to see you at an upcoming Techstrong Learning webinar. Everyone have a great rest of your day. And Guy and Mo, again, thank you so much.
Thank you, Cody. Everyone.
Have a good day. Bye-bye.